Okay, class, let's further address the posterior pituitary. Remember, the posterior pituitary had it is neurological, basically. And here are two nuclei, which we talked about previously. This is the paraventricular, this is the supraoptic. The paraventricular mainly does ADH, the supraoptic does oxytocin. But many say that there's a 1/5 crossover, which means 1/5 will come from either one, respectively. Okay, so contains axons of hypothalamic neurons. So here's the cell bodies. Here comes the axon down here. Synaptic end bulbs here. That's where the hormones. Again, neuroendocrine cells. Hormones stored and secreted versus neurotransmitter substance. The two hormones, ADH and oxytocin. ADH and oxytocin are released because of these action potentials coming down, nerve impulses, action potentials, causing at the synaptic end bulb, the vesicles are containing hormone. Both use the phosphoinositol phosphate calcium storage method at their targets. Okay, so when they reach their targets, this is the secondary messenger, because remember, these are proteins and they cannot enter the cell, so they must use what? A secondary messenger. And the two we talked about primarily was this one and cyclic 3,5-AMP, adenosine monophosphate. Okay, oxytocin stimulates uterine contractions during childbirth by mobilizing calcium through a PIP calcium secondary messenger. Obviously, calcium is needed for contraction. This will be discussed more thoroughly in the reproductive. Also triggers milk ejection, and this is because it will trigger the myoepithelial cells in the lactiferous sinus to contract and basically release the milk. Okay, but again, talked about in the reproductive. Plays a role in sexual arousal and orgasm in males and females, has some role within that to some extent. Again, will be discussed. Okay, ADH, antidiuretic hormone. This particular hormone was discussed in the cardiovascular section and also in the renal section. Okay, so this is more of a review from the aspect of endocrinology. The hypothalamic osmoreceptors respond to changes in solute of the blood. Remember that I told you the body has no way of directly detecting how much water you have. No way. We talked about this before. Even though the body is 56 to 60% water, there's really no water meters per se. Everything is being determined through osmotic pressure. Now, we talked heavily about that previously, and I also talk about in ANP1. So if you want to, you can go back into my PowerPoints and my website and look. So ADH, diuresis, is a term for urination. Another term for urination is natriuresis. So ADH is against urination. It retains the urine, shall we say, decreases urination. Okay, so if osmotic pressure of the blood is too high, if the milliosmolar pressure of the blood is too high, then that would imply to the body that you don't have enough water. Because if the solute concentration is elevated, then the body would assume that's because there's not enough water around. So then ADH would come in and be secreted to cause retention of fluid, which would decrease the osmotic pressure. So let's go again. If solute concentration is high, osmoreceptors depolarize and transmit impulses to the hypothalamic neurons. Okay? Remember, the osmoreceptors are in the hypothalamus. Okay, then that would cause the paraventricular nucleus neurons primarily to secrete ADH. ADH is synthesized and released, inhibiting urine formation, which then would raise the water level. So you have several areas to look at this. One is in cardiovascular, another in A&P, another is a handout that's within my website on osmotic pressure of the blood. Okay, all right. If solute concentration is low, then you need to urinate more, what the body would think, in order to get rid of water to increase solute concentration. Okay. Alcohol, drinking alcohol, inhibits ADH release and causes copious amounts of urine. So people, when the person drinks, this alcohol inhibits the ADH, and that causes them to urinate a lot with the drinking alcohol. Okay, let's go further. Homeostatic balance of ADH, diabetes insipidus, and the syndrome of inappropriate ADH secretion. Okay, class, as we alluded to, some homeostatic imbalances, pathophysiology involving ADH. Okay, here are two diametric opposite conditions involving ADH. One is where there's not enough ADH, and the other where there's too much. The not enough ADH deficiency, the term for that is called diabetes insipidus. Okay, now this is different than diabetes mellitus. Mellitus means sweet urine. Okay, diabetes mellitus is when they had the blood sugar. This is diabetes insipidus. In both cases, though, something is low. In diabetes mellitus, it's an insulin problem, either being low or not working. In this case, it's an ADH. Okay, let's look at it. You have a huge output of urine. Let's just think of it. What happens is it may be due to head trauma, a pituitary tumor, maybe you had surgery. But what happens is the ADH is not being secreted adequately from the posterior pituitary. When that occurs, then which means that you're releasing more urine because you're not inhibiting it. That causes large amounts of urine to be. So the urine specific gravity goes down because it's less concentrated. The osmolarity goes down. You increase your thirst because you're losing too much water. Tachycardia will occur. Go to cardiovascular, because when cardiac output goes down because of stroke volume going down, then you're going to speed up the heart to try to keep the mean arterial pressure. Blood pressure will go down unless tachycardia can hold it. Okay? So this is diabetes insipidus. Okay? The other one is too much. So let's look at that one. Okay? So in this particular case, what we're looking at is called the syndrome of inappropriate ADH secretion. The syndrome of inappropriate ADH secretion. In this particular case, you have increased levels of ADH. The renal tubules, go back to kidney, become permeable to water. So let's look at this. Right here, you want to go back to this countercurrent exchange and countercurrent multiply system. Remember, this is the collecting duct. The collecting duct is impermeable to water unless ADH opens up the doors to water, the aquapora doors to water. Okay? If ADH is there, then the doors to water will open up. So as water in the tubule comes down, remember out here is hyperosmolar. So as water comes down, if you open the door, water will be sucked out from the tubules and retained in the body. So ADH opens these water doors. Okay, opens these water doors. Now what that would do then is you would have a decreased urine volume, an increased urine osmolality. Why? Because of the fact that more solute, because you lose the fluid is increasing. Okay, so the fluid is being retained, urine volume is going is decreasing, what you're urinating. Okay, the urine that you are urinating is more concentrated. Okay, and you have an increase in urine sodium. Why? Because of the fact that you have less volume of the urine. Okay, the blood volume goes up. We talked about, because you're holding more fluid, you become hyperosmolar in the blood because you're holding fluid. You can have nausea, vomiting, hallucinations, depending on how much you affect the blood osmotic pressure. Okay. All right. So that's ADH. Now we're going to look at the thyroid gland. But I'm going to start a new one for the thyroid gland.